So the previous two examples showed how to calculate elasticity. In this case, we went from point A to B and got an elasticity of 0.111. We went from B to A and got an elasticity of 0.25. Well, the book makes an argument. The author of the book says, well, these elasticities shouldn't be that much different because we're just going from one point to the other. As an editorial note, I disagree. I think they are fundamentally different because it depends where you start from. However, we're going to show you that what the book argues is another way to address this issue is to do what's called the midpoint method. And what this method says is when you calculate the percent change in quantity, rather than use the start quantity, instead use the midpoint of the two. So we would calculate this as the elasticity of demand is equal to the percentage change in quantity, so it's still Q2 minus Q1 divided by the midpoint between Q2 and Q1. So just to kind of show you how this looks over here, Q2 minus Q1, so let's go from A to B. So we get 80 minus 90, and we do the midpoint. And the midpoint we can just visually see as 85. Well, the way we actually calculate midpoint looks just a little uglier. We do Q1 plus Q2 divided by 2. And that's the mathematical equation for the midpoint. So in this case, it would be 80 plus 90, which is 170, divided by 2, which is 85. We divide that. So now this is where it's starting to look really ugly, and that's just the reality of it. Economics can be ugly. So can children. That's a story for a different day. So we get P2 minus P1, which in this case, P2 minus P1 is 20 minus 10, divided by the midpoint. Well, the midpoint between those two is 15, but the way we'd mathematically write that is P1 plus P2 divided by 2. And so here is the equation we get, which is ugly looking, but intuitively should make a little sense to calculate the midpoint. And so when we do that, we get 10 divided by 85 divided by 10 divided by 15. So here we get the elasticity of demand to be 0.176. Now the nice thing about this, so we just calculated it going from A to B. If you were to recalculate this of going from B to A, all that would change is these two numbers would flip. It would now be 90 minus 80. 85 would stay the same. It would be 10 minus 20. The 15 would stay the same. And we would get the same answer here, 10 over 85 divided by 10 over 15, and we get the same elasticity of demand. So that's one reason why the book argues for the midpoint method is going from A to B will get you the same answer as going from B to A using the midpoint method. Now, you might ask, well, what method should I use? Both. The book presents both. I think there's value to both of them. And the questions you'll be asked will be very clear as to which method to use. If it says calculate the elasticity of demand, you use the original method that we had before, where we use these numbers here. If it says using the midpoint method, then you would absolutely want to use the midpoint method.